Engine repair 2, engine repair 2, test 3, that is correct, Curtis. Now we are talking a little bit about some gasoline and stuff like this. We have to go through this every time we learn about engines, either an engine repair 1 or 2. So we're going to talk a little bit about the gasoline, and we're going to talk about winter blend gasoline. Did you know there was such a thing as different gasoline in the summer than there was the winter?
No.
Well, there is. And number one, the first question is winter blend gasoline what?
See?
Can cause engine drivability problems if used during warm weather. Vaporizes more easily than summer blend gasoline. Has a higher read vapor pressure.
D.
All of the above. Here's something else that most people don't know. If an engine is set up by the manufacturer, fuel injection engine particularly, if it's set up to run on 87 octane and you put 93 octane in there, you may find out that it doesn't run worth a flip when it's cold. There was a boy that was working close to me right there that was in the facing service bay when I was at the Ford dealership, and he drew a warranty repair job on a Bronco, big Bronco back in 92 or 93 whenever it was brand new, and they said it ran terrible when it was cold. It just fall on its face and pop and snort and cut up. And he worked on it. He cleaned the injectors. He did a bunch of work on it, about half a day. You know, he checked and rechecked the timing and all that. We ran the code, you know, looked at the data stream there. Well, he couldn't get any satisfaction. He kept, you know, he let it cool off a little bit. And I says, why don't you go out there and ask them what kind of gas they're burning? Don't say, are you burning premium gas? Just ask them what kind of gas they're burning. I bet you they're going to tell you they're burning premium gas. So he goes out to the write-up area and he says, what kind of gas are you got? Oh, we're putting 93 octane, best you can put in there. I said, okay, well, he came back and I said, what did you tell him? He said, well, I told him to take it and burn all of that gas out and put some regular in there. They wouldn't have any trouble anymore. You know, Ford and Chrysler came out with TSBs. It says if you put 93 octane where 87 goes, you're subject to cause carbon in the combustion chamber and all kinds of, you know, because what's the difference between premium gas and regular gas? It burns slower. Premium gas burns slower. Got it? That's what the primary deal is. And if it doesn't all burn, what happens? What's left coats the top of the piston, starts to cake up its carbon. It can actually, over time, as it puts layer after layer, it can coat all of that so that the combustion chamber gets smaller. And if you take up room in the combustion chamber, what have you done? You've increased the compression. If you increase the compression, you can get detonation, ping, labor knock. Have you ever heard one diesel when you shut it off? Back when carburetors used to be on just about every car that we were working on, if you had a bunch of carbon, little glowing coals of carbon up in there when you shut the car off that were hot enough to light off the air, even though you killed the ignition, the air that was being drawn into the engine through the carburetor would light off with those little glowing coals of carbon whiskers in there, and it would go doom, 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 you know. You ever heard that?
Yeah.
You shut it off and it just tries to keep running. I mean, you couldn't drive it that way, but it's going boom, boom, doom, doom. There's a show that's got Steve Guttenberg on it called Don't Tell Her It's Me. And there's a cute little dark-haired girl in that show, and she's driving a big old Buick. And she pulls up in front of a house and gets out of that car and goes in the house, up the stairs, and looking around upstairs for somebody. And the whole time she's in the house, that car's sitting there dieseling, doom, to doom, 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 to doom, 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 blowing out smoke and all. And then when she came back down, she switched it back on, and it was running normally again, and she drove off without even having to start it back up. You know, but that's what diesel is all about. I like to, you know, cover that in his fuel business. Technician A says spark, knock, ping, detonation are different names for abnormal combustion. Have you ever heard any of that? Have you ever heard something like if an engine starts to get too hot, or if the timing is set wrong? Like when you're going up a hill, you'll hear something that sounds like somebody rattling marbles in a can under the hood. You're like, it doesn't really. It's not like a cadence of bop, 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 bop. It's basically like just a rattling noise. And so what happens is something is causing that spark, the combustion event to happen before the piston gets to top dead center. If you've got the ignition timing on one with the distributor adjusted a little too far, like you turn the distributor to set the ignition timing right on like a 350 or the ones we got a distributor like the Bronco. If somebody sets the ignition timing where it's too advanced, when you're driving along going up a hill and it has to advance the timing on up there, you know, because of engine speed and all, it can actually be lighting off the mix before it needs to. The piston's still on its way up it's not time for that flame front to hit the top of the piston and push it back down. It hits it on the way up, and it actually causes it, it feels like it's got enough force hitting the top of that piston, and it's almost like hitting it with a hammer. Only it's not making dents in it. However, if it's bad enough and long enough, it can bust a piston. It's bad. Detonation, ping. Detonation typically is because the engine is too hot. If you've ever driven an engine to where it got so hot that it quit? Have you ever driven a car where the engine got so hot that it quit? What did it sound like? You hear that pop, pinging stuff up under the hood, and that's basically what you're hearing. That's detonation. Ping is the same thing. Spark knock is the same thing. All right. How many of you have heard on your engine control system you got a knock sensor? Just about every engine has a knock sensor on it. You ever heard of that? You're going to get codes for them sometimes. They got a knock sensor, and it's basically a little donut-shaped sensor. It's got wires coming off of it, and it bolts down in a place to where it's going to pick up on that 5,555 hertz, vibration, that cyclic vibration that comes from an engine knock. Okay, and so basically what you got there with that engine knock, the engine controller is listening for that particular knock. Now, it's also listening to it in a window where it knows knocks will happen. There's a certain window of cylinder travel where a knock is going to happen if it's a timing or related or fuel related knock. How many of you have heard of bad fuel causing pinging or labor knock or something like that?
A friend and I were just talking about that yesterday.
Now that is because the fuel is too explosive. Have you ever smelled bad gas? If you ever smell bad gas and you get some on you, you'll be smelling it for a couple of 3 days. Have you ever singed your hair? You guys haven't worked on cars as much as I have you? Singe your hair.
You don't have to singe your hair just by working on cars.
Well, I have definitely singed my hair
You just have to have a
working
little
on
weather.
cars. Yeah, and looking over the carburetor, and all of a sudden, boom! It backfires, and your hair is singed and all that stuff. And so when you take a shower, you smell singed hair coming out of your hair. All right, and you take a shower the next day, and you still smell singed hair. But I mean, it's irritating. Well, bad gas is the same way. But when you start smelling gas that's going bad, that gas is moving more and becoming more and more and more explosive. And it's easier for it to light off when it's not supposed to. And it causes ping and labor knock and all that kind of stuff. That's abnormal combustion. Technician B says, any abnormal combustion raises the temperature and pressure inside the combustion chamber and can cause severe engine damage. That is true. Now, remember we talked about EGR. Who got in on a little EGR seminar I did? Whatever EGR is flowing, the engine runs really bad because it's trying to cool a combustion chamber by putting some inert gas in there, right? Okay, if the EGR is not working, it can cause ping because you have the time in advance a little more because you're expecting EGR. If something happens that stops the EGR from going on, it can cause ping. Let me clarify that. You won't always have ping when your EGR stops working. Typically, they have it now where you won't. In the early days of putting EGR valves on in the early 70s, if it wasn't working, you would have a ping, if the EGR wasn't working on some vehicles, not on every vehicle. Some of them would ping bad enough where it would damage the engine if you drove it very long without it. Technician A says the research octane number is higher than the motor octane number. Technician B says the octane rating posted on the fuel pumps is an average of the two ratings. Who is that? Who's right about that? You ever seen this on a pump where it says R plus M divided by 2? You ever seen that? Research plus motor divided by 2. That's an average of the two. So basically, they measure the fuel. They got a way that they use that they measure the volatility of the fuel. They got another way they use an engine to measure it, apparently, because that's why they call it motor. And then they take those two numbers, they add them together, and they give you the average of those two numbers. That's what R plus M divided by 2 means. And that's what this question's about. Technician A says the research octane number is higher than the motor octane number. Technician B says the octane rating posted on fuel pumps is the average between the two ratings, and that is C. Technician A says in going to high altitudes, engine produce lower power. Technician B says most engine control systems can compensate the air-fuel mixture for changes in altitude. Who's correct? That's correct, but if it's, the last time I heard, if it's more than 4,000 feet, like if from sea level to 4,000 feet, most of your engine control systems can use the barometric pressure sensor to make the necessary changes to make it run okay. Now, they may have changed that, but the last I heard, up to 4,000 feet, you were okay. If you got over 4,000 feet, modifications have to be made. On some of them, like on the older Jeeps, there was a ground wire that was black with a white stripe on it that was down there by the dipstick bracket that was not connected. It was taped back into the harness. If you were going to take one of those Jeeps, like an old 4-liter Grand Cherokee or something, to high altitude, like if you, what's the altitude in Colorado? I mean at Denver?
8,000.
No. There's a reason they call Denver the Mile High City. It's a mile above sea level, right? So if you go up there, you know, in an altitude that's that high, now it's interesting that you would say, if you asked a trivia question, if you could say, if I was going to take an altitude line and I was going to draw an altitude line from Denver to the Grand Canyon, to the rim of the Grand Canyon, did you know that the rim of the Grand Canyon is higher in altitude than Denver, Colorado? It's 8,000 feet. But the long and the short of it is, if you're driving in a place like that where you're at high altitude and your car's been used to running at sea level, you know, and you get above that 4,000 foot threshold on one of the cars I'm talking about, your timing has got to be advanced. So on the Jeep, what you would do is they had a crank sensor that actually would be in a different spot. Like, see that crank sensor over there reading off that wheel? That Jeep actually had a crank sensor that was mounted in a spot on the bracket where it would advance at 8 degrees. So your ignition timing would consistently be higher because you got to have more time for it to burn because there's less oxygen up there. And you're actually going to have to change your air fuel mix. And that's why you would ground that wire that was black with a white stripe if you were going up there, and you'd have to put a different crank sensor on it. And incidentally, think about this. What if I'm at sea level and somebody sells me a crank sensor and it happens to be an altitude compensated crank sensor? I'm running ignition timing is too fast now, right? And I'm going to wind up with a ping, which is labor knock, like you got the timing set. Because you can't turn the distributor and set the timing on those, because the crank sensor, hear this, some of them will have a distributor, but if they got a crank sensor and a distributor, you cannot set the ignition timing by turning the distributor, because the distributor is not where the signal is coming from that's firing the coil. All right, let me see here. What can be used to measure, wait a minute, number 4 was actually C. What can be used to measure the alcohol content in gasoline?
D.
What was that?
D.
D, yeah. You can basically use either a graduated cylinder or an electronic tester. And in my engine repair 1, I've basically got a graduated cylinder, and I give you some alcohol laced gas so you can do that. Why is that necessary? Why is it a big deal? If you're doing engine performance work and you've got a vehicle that runs lousy and everything else is right, and you're trying to figure out why it runs lousy, before you throw an engine controller on it or spend money on a bunch of other electronic parts, it's not a bad idea to see what kind of fuel you got in there. Look at the fuel quality. And if you've got a bunch of alcohol in it, how would somebody get a bunch of alcohol in their fuel?
I guess by
Stopping at the pump and taking the E85 nozzle and pumping it into their car because it's 85% alcohol. That's for flex fuel vehicles. And I'll tell you something else. You'd be surprised which vehicles you work on that are flex fuel and you didn't know it. They don't all have badges on them. Sometimes all you can tell is by the serial number on the car. But basically, and it'll be the 8th digit will be different on the one that's flex fuel. But there was a Dodge truck that came in here. The guy says, I filled up my gas tank, I drove 2 blocks, and it quit. And it hasn't started since. And so we brought it in here. The fuel pump was running. It had good fuel pressure. And I says, I wonder if he picked up some water from that gas station. And so I got a hose and I connected it to the outlet, a hose coming out of the tank, and I put it in a container big enough to hold it, you know. And of course, you're supposed to put it in a, approved container after you're actually looking at it. But if you're trying to look at the gas, you got to have it in an open container while you're pumping it out. And we just ran the fuel pump until it was out of gas, while letting it pump into this, big pan. Because if there's water in there, if you run it completely out of gas that way, you're going to see that water, right? I've actually done that at the dealership before. You can see the water in the thing. Well, I didn't see any water in there. And you could take that gas and you could put it on your hand and swish it around. I've seen diesel fuel in the gas, and I'd just stick my hand there and swish it around, and whenever it gets dry, it smells like diesel. This wasn't like that. It looked good, it smelled good, it had no water in it. But I decided that I was going to take some gasoline out of our tanker and pump it into a 2-gallon jug and pour it in there, and it fired the truck up. I have no earthly idea what was wrong with that. I tested it for alcohol, no alcohol in it. I don't know what's wrong with that gas. You can't look at it and tell a lot of the time. Sometimes the best way is to get the gas out of it and substitute some good gas. That's a lot smarter than buying an $800 engine controller, right? Okay. It's also important to get a good story, good information from the customer. There was another guy, he says, I'm driving my truck out in the country, it quit on me. I loaded it on the trailer, he said it wouldn't start. So I loaded it on the trailer, he brings it to the Ford dealership. He lets it off. I draw the work order on it. I look at it, I walk out there, it's a 2-tank truck, right? It's got a front and a rear tank. So I'm looking at the tank switch is on the front tank. I say, okay, that's significant information. I'm gonna test it on the tank that he had it on when he was driving and it quit, right? So I'm going to spin it over, and it's sure enough, it starts really, really hard, but about 45 seconds of spinning, when I spun it, it wouldn't start, and I was going to go down there and check stuff, and when I went to try it again to check spark and whatnot, it fired up. I said, doggone it. And so I fooled with it and worked with it and tried to figure out what was wrong with it and checked the fuel pump and all that, and I never, saw anything. And so he came to pick it up, and I don't know if we charged him a basic charge or just didn't charge him anything. He headed out of the dealership, and he got out there at the road, and it quit on him again. And so he came walking in. He says, come look at it. It quit on me again. And I walked out there. I got in the car, and I looked. It was still on the front tank. And I says, can you tell me exactly what you did when you were pulling out of here? He says, yeah. When I was pulling out of the shop, I put it on the rear tank. And then it died, and I put it back on the front tank. Okay. The rear tanks are pancake shaped, and they like to get a lot of condensation. They like to fill up with water. So I said, watch this. And it spun hard and cranked up after about 45 seconds the same way. And I said, while it's running, I said, let me show you something. And I held it up to about 2,000 RPM, and I flipped it to the rear tank, and immediately it started to die when it started drawing out of the rear tank. And I flipped it back to the front tank, and it caught back up. And I said, you got water in that back tank back there, buddy. Pull that tank off and let's clean it. This is how much it's going to cost. No, now that I know what's wrong with it. Well, he never told me I switched it to the rear tank and it quit. He didn't think that was necessary information for me to know, but it would have helped a heck of a lot, and I would have figured it out a lot sooner. Okay. Okay, hang on just a second. This is my dad calling. Hey. Yeah. I don't know. We'll have to check with David about that. Uh-huh. We'll get one. I'll talk to the people that are doing our taxes, and we'll see what we got to do to get one. I'll let you know something. All right. Bye. All right, here we go. Let's see. E85 means the fuel is made from what?
85% ethanol.
Yeah, and 15% gasoline. And a car that's set up to run on flex fuel can run on any number of, any percentage between there. A flex fuel vehicle could be identified by what?
Then you do both.
Yeah, VCI VIN. And emblems on it. You don't always have emblems. You can usually find it on the other two. When refueling a compressed natural gas vehicle, why is it recommended the tank be filled to a high pressure? You can go farther. The range of the vehicle will increase. What color is diesel fuel dyed if it's for off-road use only?
Red.
Yeah, that's red. And I've said this before, but when I was working on those Power Stroke diesels at the dealership, if somebody said my truck's not running right, and I took the top off of that fuel filter in the middle of the top of the engine, and I saw a bunch of red fuel in there, I'd put it back on, drive it outside, and I'd say, run 3 tanks of regular gas through regular, on-road diesel through this thing, and bring it back, let's talk about this. A lot of times that'd clear it up, because that off-road diesel puts gel in the injectors and all that kind of stuff sometimes. Technician A says, gasoline is a complex blend of hydrocarbons. We talked about that on the board, talking about the mix. Technician B says gasoline is blended for seasonal usage to achieve the correct volatility for easy start and maximum fuel economy. That is C. Most regular grade gasoline today, using the R plus M divided by 2 rating method, is which of these octane ratings? What do you usually see on the pump, y'all? Don't play dumb. 87 is what you're going to see. I mentioned that number earlier. And don't use 93 octane if your car is set up to run 87. That's what I was telling somebody the other day that I knew that was topping off their vehicle with 93 octane. One that should avoid topping off their tank because what?
Charcoal canister.
Yeah, man, that may saturate the charcoal canister. And if it starts trying to purge that canister and it's saturated, it may make the engine almost die and kick back up and do all kind of crazy stuff. Which of these is added to a fuel for tested purposes to avoid problems with variation of gasoline? Indolene.
Oh, wait, wasn't that what you were saying about the, was it, you were in Texas and...
It wasn't Indolene. I ran out of gas.
Yeah.
My daughter and my son were with me. She was a little bitty thing. She was like 5 and my son was, had just been born. And I'd run out of gas and down there close to Texaco Research, and I had $50 in my pocket, but I just went right by a gas station, goofball, wasn't thinking. And so I walked over to the door. The guy came out with a lab coat on. He handed me a bottle. I said, I need some gas, or to pay somebody to take me to get some gas or something. And he handed me this white glass bottle with a cork in the top that said toluene. He said, here, pour that in there. It'll run off that. Well, I mean, Texaco Research, the guy knows what he's doing, So I poured it in there and it fired up and I drove back to the gas station. But I bet nobody else has had that experience. Vapor lock can occur under which of these conditions? And what the heck is vapor lock anyway? Try boiling the fuel in the lines. If it's boiling in the lines, you got air in there, and you can't run on air, can you? So if you boil the fuel in the lines, I had a Jeep I worked on one time at the dealership, and it would vapor lock. It had a carburetor. It had a fuel pump that was one of these old diaphragm fuel pumps driven off the camshaft. And that thing had a weak fuel pump, and that was what was making it vapor lock. Now, the reason I knew that that was what was making it vapor lock was I took rubber hose and I bypassed the metal lines that were running down there close to the exhaust, but it's still vapor locked. And when I put a new fuel pump on that thing, those rubber hoses that I had put on there were just bouncing with the pressure that was going through them. And before that, they weren't even wiggling at all. And so basically, if you got a good strong fuel pump, you're less likely to have that. Here's another thing. Let's say you're going out there, or you hear somebody come in, they say, my vehicle quit and it won't start, right? And they said, I opened the hood and I mashed that little Schrader on the fuel rail, and all kinds of fuel just sprayed out of there like a fire hose. And so I know it wasn't a fuel problem. Well, they just indicated that it is a fuel problem, because what's going to make that fuel spray out of there and just a lot of air pressure. Air pressure, not fuel pressure. If you've got good solid fuel in there, even if you got the right amount of pressure, you may see it go on your hand, but it's not going to fire hose out of there and go up here and hit the hood and splatter out everywhere. That basically means, and fuel pumps do this, they'll get hot, they'll start to cavitate, they'll make air in the lines and all that. I had a dadgum Dodge van one time that I was working on that had a V8 in it. And that Dodge van had a misfire on cylinder number 1. And that Dodge van, when I worked on it, I said, well, I got a cylinder number 1 misfire. Which, on the Dodge van, the front cylinder on the left bank is cylinder number 1. And the engine's kind of sitting in there at an angle, right? Okay, so I worked on that thing for a while, trying to figure out why it was misfiring on cylinder number 1. The injector was clicking, I had good fuel pressure, and it was a returnless fuel system, meaning the fuel pressure was regulated in the gas tank by an in-tank regulator, and it was pushing up there into the fuel rail. And it was basically, sometimes fuel pumps, when they started to go bad, they'll actually whip the gas right there where they're pumping into a foam if the pump's trying to go bad, and it will push foam into the air, into the fuel line. And where that air was going was to the highest cylinder on that fuel rail. The air was getting into the left-hand fuel rail, and it was right there at the number 1 injector was a bubble. There was no fuel. There was just air there because it was a returnless fuel system. And another time, I saw a a Continental that had a 4.6 in it. It was mounted sideways, and it had a walking skip that would start. I was looking at the power balance on the scan tool thing I was using there, and it would say 1, 3, 7, 2, 6. It was a walking skip, and I called the hotline, and they said, "Man, I don't know what you got over there. That's ridiculous. You maybe put a cam sensor on it or something?" I mean, they were just totally flabbergasted. I said, "You wouldn't know it if you didn't have the power balance feature on the IDS." That time they called it WDS. It was a different, same software though. Anyway, it would skip on 1, then it would skip on 3, then on 7, and it turned out the fuel pump was cavitating, pushing air bubbles up in that fuel rail. Because whenever I had my my equipment hooked up to it, and I pushed a little bleed, like you're gonna let the pressure off, and when I did that, some air come out and it smoothed out and it stopped doing that. And I put a fuel pump in that car and fixed that. And the car only had 15,000 miles on it, but it had been traded in because the other whoever it was that was working on it at whatever dealership that it had been at before couldn't fix that rough idle, and it was an interesting little story there. Let me see.
So 14 is A, or is it
Yeah,
C?
14 is actually C. High heat near fuel lines or restricted fuel line, or a weak fuel pump. I mean, there's a bunch of stuff that can cause it. Technician A says the use of premium high octane gasoline in engine designs use regular gasoline will increase engine power. Is that true or false? That is dead wrong. Technician B says flexible fuel vehicles are designed to operate on gasoline or gasoline ethanol blends up to 85%. He's right, the other guy's not. Abnormal combustion, also called detonation or spark knock, increases both the temperature and what inside the combustion chamber?
D.
What do you think? Everybody like that answer? That's D, pressure. If methanol fuel is used, the exhaust contains what? Which has a sharp odor and can cause severe burning of the eyes, nose, and throat. Believe it or not, it has formaldehyde in it. That's what comes out there. ExxonMobil has developed a process for converting methanol, methyl alcohol, into gasoline in a process called which of these? Now, who'd know that? Methanol to gasoline, MTG, right? Which of these procedures is used to convert coal to liquid fuel? It creates a synthetic crude called Syncrude, which is refined to produce gasoline or diesel fuels. In other words, you can make gasoline out of coal, right? That's B, direct method, which is, who would know that? The fuel in a CNG fueled vehicle is stored at a pressure high as 3,500 psi. The compressed natural gas is delivered to the mixer valve at a pressure of what? 1/2 of 1 psi. You got that? Now, believe it or not, you can buy vehicles that are compressed natural gas fueled in some makes. Just buy them like
I
that.
saw one driving around downtown Andalusia.
Yeah.
It was a Civic. Actually, it wasn't, yeah, it was natural gas.
The gas company, a lot of the times, they'll have their vehicles. I worked on a, did you know that if I guess the law is just like it was, years ago, when I was at Ford dealership, there was a truck that was one of our trucks that was broke down, quit running. It was a brand new truck, but they were running it off natural gas. And basically they had adapted it to run off natural gas, and their injectors were just clicking dry, but they were feeding the natural gas in there. And the thing quit up there by a pond where they had gone out to fill up a tank, a gas tank. It was a big gas truck. The gas truck, it looks like a big tank on the back of it. It's got, so that whatever. And I went over there to start that thing and to figure out what was wrong with it, because you can't pull one of those with a wrecker. You cannot drag a natural gas truck with a wrecker. I think it's against the law. I was told that. That's why they told me to take whatever you can think of, drive to Montgomery, go out there in that field with this guy and fix this dadgum truck. And I didn't have no clue why the thing quit, but I went up there and figured it out. Anyway, and what happened was I drove all the way up there, and when I did all my testing, I found out one of the connectors out there feeding the ignition system wasn't quite seated, and it was a brand new truck, and I just went click and it fired. But who could have found that? I just happened to look at all the connectors, make sure they were seated good, which is a good thing to do that. And that was the end of that story. But anyway, remember that if a natural gas truck breaks down, it's too dangerous to pull it behind a wrecker, because if you have a crash, you got a Smokey the Bear won't like it. It's a movie grade explosion, and you don't want that if you can help it. Huh?